Hi guys, so today we're just going to take a look at how to draw with shapes with processing, and then you'll be given a task to do, which I will follow up with on tomorrow. The main thing I'm going to look at is, did you fill in this handout? In tomorrow's class there'll be a quick check done, so make sure you are filling in the notes. I've left the handouts with the supply teacher, so give it a whirl. So we're going to actually take a look at processing today, and your task over the next couple of days is to create a drawing using all of these shapes. So just to start with the grid, we have our coordinates 0, 0 in the top left corner. And remember that y increases as you go down and x increases as you go to the right. So let's take a look at how each of these shapes are drawn with these commands, and then we'll look at some sample code to see how you can structure that to actually create a drawing, and some add-ons that you can use to make it colorful and dynamic. So the first one is the rectangle, and the rectangle, notice the top left corner of the rectangle is actually what these XY coordinates designate, and that gives you the full width and the full height. So the rectangle is located at 100, 100. So if we actually go, let's say each of these lines is 100, so 100, 100 would be right here, and that's the top left corner, and it's got a width of 1, 2, 300, and a height of 200, so this is the shape that we've just created. There is our rectangle. Clearly the computer would do with straighter lines than my shaky hands. The next shape that we're going to look at is the ellipse. The ellipse, the XY coordinate actually designates its center, and it's got a width and a height. Notice these are not radii, these are diameters. This also allows us to make ovals if we want, or circles if they're the same dimension. So the ellipse's center is at 100, 350. So at 100, 1, 2, 3, 50 is the center of the ellipse, and it has a total width and a total height of 50. So that actually means that it's not even going to reach the end. It's going to be something like this. There is our circle. The total width of 50. The total width will be roughly half of one of these boxes. Looking at the triangle, the triangle's coordinates are actually a series of 3 vertices. Each one is an XY pairing. And those will be the corners of the triangle that we would then join together. So 600, 0 is our first coordinate. So 1, 2, 3, 4, 5, 600 and 0. And then the second coordinate is going to be 600, 200. So we're here at 600, so it's 100, 200. And the third coordinate is 700, 100. So if this is 600, that's 700, and this one here is 100. And there is our triangle. The next shape we're going to look at is a quadrilateral. The quadrilateral, you can actually see, is much like the triangle. We actually have 4 sets of coordinates. So let's plot those 4 coordinates on this grid, and then we'll join them together to create a quadrilateral, 4-sided shape. So our first one is 700, 200. 1, 2, 3, 4, 5, 6, 700 and 200. And then 600, 400. Then 800, 400, and then finally 800, 300. We'll connect all those up, and the order does matter for the quadrilateral. If you mix these coordinates around, you might get something that zigzags and crosses and things like that. You might want to try it out. Could look cool. Give it a whirl. The next shape is going to be a line. In the line, you just give the 2 endpoints of the line. It connects it together for you. So we'll draw this line, 200, 400, and 600, 300. So we have 200, 1, 2, 3, 400, and then 1, 2, 3, 4, 5, 6, and 1, 2, 300. And we'll connect those 2 together, and there's our line. The last shape is an arc. Now, arcs are tricky because arcs are actually like a piece of a circle. So like it would be something like that, right? A piece of an outline of a circle. And if you fill them, the arcs actually create like what looks like a slice of pie, and you can actually make it so that instead of making it a slice, you can actually make it so it's like a section like that. That's called using a chord, and we'll take a look at how that works in a second. So the coordinates for an arc is as if we were to build a circle with these properties. So first we provide it with the same information as an ellipse. These 2 coordinates are the center, this is the total width, and that's the total height. Then we actually have where to start rotating and where to stop rotating. What do you mean by rotating? Well, you can have like segments of a circle, and it can be almost any segment. So how do you tell it which segment it's going to be? Taking a quick look over here, taking a quick look over at the Google Classroom, creating arcs is one of the documents I posted for you. You can actually see a little map here where the start radians, 0 is over here on the right-hand side of the circle, or the eastern point, and it rotates clockwise around the circle. This is actually upside down from how you're going to learn it in advanced functions, but for our intents and purposes, it's just fine. And so notice, if I started at 0 and I went to 90, I'd actually create that lower right corner of the circle. If I started at 90 and went to 180, I'd create that lower left corner of the circle. So if we actually return back to the handout, that first circle is centered at 750, 100. So 750, this was 700 here, this is 750 by 100. There's the center. It's got a total width and height of 100, so it's going to be something like that would have been the circle, but that's not the actual shape that will be drawn. We're actually going to draw from radians. So radians converts this degree measure from something we understand into a radians measure, which is what the computer understands. We start from degree measure 0, and we stop at degree measure 180. So we start at 0, which is here, and we connect around the circle to 180. And that little smiley portion is the part that we want. If we added a parameter here, so I'm just going to scribble out this last bracket and the semicolon and add a comma and said chord in all caps, close the bracket and add back the semicolon, that actually makes it so that we connect those two lines, the endpoints, together to create a closed shape. Okay, there's one more thing I'd like you to do, and that's on the back of this handout. There's some sample code. I want you to play around with some of these settings. Some things to note here is this is the total size of the canvas. That's the total size you have to work with. Background can take a three-digit color code. And if you take a quick look here, you can just Google HTML color picker and it will take you to one. And if you select a color, it tells you the RGB code right over there. And that translates directly into what would end up in the background, in stroke, and in fill. Stroke is a border. Stroke weight is how thick that border is. Fill is what color the shape would be in. And then all of these settings would apply to this rectangle here. No fill would remove the fill color, and you just see the background. And one more is no stroke. Notice that S is capitalized and nothing else is, with a semicolon at the end, would actually remove the color. In fact, it would remove the border altogether. So these two would apply to this rectangle, and if I were to remove these slashes, it would also apply to this ellipse. Okay, hope you found this helpful, and I will see you guys tomorrow. Remember, once again, your task today is to create a static drawing, or at least get started on it, of something, not just a pile of shapes. Create a drawing of something. And feel free to check out some of the samples that I posted to the Google Classroom. And I will be following up tomorrow by checking your handout to make sure that everything has been filled in according to how I just did it. And we will continue work on this then. Okay? Have a great day.